This is the second in a series of video-based lessons that will introduce the basic programming lingo and describe several high-level programming concepts. We begin with a brief introduction to computing with few definitions, explain why we made the choice to use Visual Basic, and provide a simple, motivating example. We then describe the main steps in the programming development cycle, explain the basics of software life development cycle, or SDLC, present a few handy programming tools, and finish by describing each of the three basic programming structures. This material is covered in Chapter 1 of our textbook. So what is programming or coding in general? Programming is nothing more than solving problems using computers. The problem is translated into a series of tasks, which are then executed in order to obtain a solution. The programs are written or coded using a high-level language, such as Visual Basic, that is relatively easy for a human to understand. English language words with specific meaning are used to build a program, and then a translator program, also known as a compiler or interpreter, much like a human language translator, takes over. It converts the program into computer's own language of zeros and ones and executes the sequence of tasks, producing a desired solution. These programs, written in a high-level language like VB, typically consist of some kind of graphical user interface, GUI or GUI. GUI is a collection of windows, buttons, drop-down menus, and a host of other interaction tools you find on a typical website or a smartphone. A programmer, also known as developer or software engineer, is a person, or more likely a team of people, that created a program. A user, like you and me, are people actually running or executing a program on our computers and phones. So why Visual Basic? VB provides for a relatively gentle introduction to basic programming concepts and simple event-driven application development. It forms a basis for VBA, or Visual Basic for Application. More specifically, Excel VBA, aka Excel macro programming, which you are most likely to use in your future careers. It can be used to quickly mock up an application design, especially for non-professional programmers. Suppose you want a program that will calculate a monthly payment on your car. Using Visual Basic, you can quickly drag and drop few labels, text boxes, and buttons, write few lines of code, and monthly payment magically appears. Actually, there is no magic, as the next slide explains. In a nutshell, every program has three main steps. 1. What is it you want the program to do, i.e., what is the output of the program supposed to be? 2. What does the program need to produce that output, i.e., what are the inputs to the program? And 3. How are we going to get from one to another, from input to output? In other words, how are we going to process our input to get the desired output? In our simple payment calculator, we want to calculate monthly car payment, so that is our output. What data do we need so we can do that? We need the amount borrowed, term of the loan, and the interest rate our customer will be charged for borrowing that money. So there are three pieces of input needed to produce one output. The processing, in this case, is a math formula implemented in the PMT function, the same one you might have seen in Excel in your Intro Finance class. As you know from your Intro MIS class, the process of developing an information system, aka Software Life Development Cycle, or SDLC, is the industry standard for software development. For real-life problems, much more complicated than our simple financial calculator, a carefully crafted plan, a step-by-step process, is called for. Review the SDLC steps on this in the following slide, starting with gathering of requirements and analysis of the problem. Once we generally understand what is it that the program is supposed to do, we proceed to the design stage, where a problem-solving plan is designed. Data is collected, calculations and transformations are determined, and the output is presented to the user. The user typically has significant input to the user interface design, so you need to be prepared for some back and forth until the final design emerges. Implementation step involving coding and extensive testing comes next. If a user types an incorrect percentage, the PMT function will not be able to calculate the correct payment or any payment at all. User entry errors should be minimized or completely prevented, but they always have to be gracefully handled so that the entire program does not crash the website and leave the user with an undesirable experience. Documentation is part of every one of the SDLC phases, but is emphasized here in the context of programming. You will see us using internal comments extensively in this class. Software developers provide extensive technical documentation of their code, and technical writers write user instruction manuals and online help. This slide defines the two basic programming tools often used when tackling a new problem. One is a flowchart, not limited to computer programming by any means, and another one is pseudocode, which is an English-like description of the tasks needed to solve a particular problem with a computer program. Out of the two, flowcharts are obviously more visual and thus more commonly used by design folks that need to see the problem from that perspective. There is a set of fairly standardized symbols used to represent different aspects of a program, such as parallelograms for input-output, rectangles for processing, and arrows for program flow. Flowcharting a smaller piece of a problem is used the most often. For complex problems, flowcharts can simply be too difficult to design and interpret effectively. The pseudocode, on the other hand, is less visual, but can, just like pages of a book, continue on and on until the problem is solved. It allows you to concentrate on a particular task or set of tasks rather than worry about the syntax of a particular language such as VB. We often mentioned that program consists of tasks needed to solve a particular problem. To dig a little deeper, we introduce three programming structures that deal with these tasks. 1. Sequence structure, where the code moves from one line to the next, executing a series of tasks. 2. Decision structure, where the code jumps around based on one or more conditions or questions. And 3. The repetition structure, where a set of tasks is repeated with different parameters a finite number of times. The flowchart on the right has all three programming structures. An example of sequence structure are the input of new customer data, payment calculation, incrementing of customer counter, and adding the current payment to the total. The decision structure asks a question about additional customers. If there are more, we do all these steps again for another customer, which is an example of a repetition structure. Otherwise, we calculate the average monthly payment for the processed customers and display it as our final result. The second video in the series provided a series of basic programming concepts and definitions. We defined programming as problem solving with computers, introduced some basic terminology, and provided some justification for using Visual Basic as a programming language of our choice. We described the input, processing, output nature of programs and reintroduced software development lifecycle methodology you learned about in your Intro MIS class. We finished by describing flowcharts and pseudocode, the two basic programming tools, and defined the three programming structures: sequence, decision, and repetition. Each program consists of a specific mixture of those three.